Okay, welcome back. In the last video we talked about an application in which the coefficient of restitution is important to solve a problem in conservation of linear momentum. So in this video I will through this topic I will have another example for you in which now so far I have been talking about examples in which the two masses travel in a horizontal direction, or if it is vertical direction. So the two objects were actually moving, whether or not they were opposing each other after collision or they were going in the same direction, they moved in a single plane. Now what happens if two objects are not in a single plane? Say one object travels in a horizontal direction initially and another object travels in a vertical direction, and these two objects collide, and what happens to the final and initial velocities, what happens to their directions? So this is an example problem in which the two masses which have velocities in two directions. Now this is horizontal and the other mass velocity is vertical at the initial instance, and we have to find the final velocities. So in this problem they have been given that the mass of the first mass is 2 kilograms. I'll take it as A, and this as B. Alright, so A's mass is 2 kilograms and its initial velocity is 10 meters per second. B's mass is 5 kilograms and its initial velocity is 8 meters per second. And we have been given that this is an elastic collision, and the A's final velocity is 4 meters per second, is still in that direction, and we have to find the velocity of B. So if we take the velocity of B in this direction, the final velocity of B in this direction, so what is actually B? So that's the question. So it's rather simple if we analyze this problem. When these two masses collide, what happens is this has some 2 kilogram velocity in this direction. Now actually we can draw this on horizontal plane. I am just drawing to explain you. So this is 2 kilograms and this has velocity of 10 meters per second, and this has velocity of 8 meters per second, and this is 5 kilograms. When these two collide each other, they will have some momentum. They will have some initial impulse. I will not mark that because we don't know actually at what point and at what direction. We don't need to find the impulse in this problem, so I will not mark the impulse for this problem. And they have been given that the final velocity of A, which is 2 kilograms, is 4 meters per second, and the final velocity of B, which is 4 kilograms, is V. So I'll draw that as if it is going down. We can find whether it is going down or whether it is going angular or whether it is going upwards from the direction whether it is positive or negative. So this is V, this is 4 kilograms. So this is A, this is B, and B, A, B, right? A and B. Alright, so we know that the mass of this object, so now we know that anyhow whether these objects collide, whether the impulse is horizontal. Now probably the impulse cannot be horizontal or vertical, it should be in some angular direction. So whether this is in which direction, however, the total external force on this system should be 0, because the force exerted by A on B is equal to the force exerted by B on A, regardless of the direction, whether it is angular, horizontal or vertical. So the total force of this system is 0, so we can apply conservation of linear momentum to this system. Now the problem in this system is that the conservation of linear momentum of one object cannot be made similar to the other object. Now in the case of two objects that were traveling in the same direction, now we can say that whether if it is going in the positive direction, I'll take the right side, this side as a positive direction, and this side as a negative direction. So I can say if it is going this side, it has positive momentum, this side it has negative momentum. So I can calculate that. Now, in this problem, we have two velocities that are perpendicular to each other. So, how can we apply the conservation of linear momentum? It is simple. It's still the velocity of this object. So, the velocity of the object we have marked. So, we can still put the conservation of linear momentum. So, we'll put the conservation of linear momentum ignoring the direction. We don't have to confuse with the direction. We'll just put the conservation of linear momentum as we have learned so far. Alright, so the conservation of linear momentum, I can say the initial momentum of this object, the velocity is 2 kilograms and its speed is 10 meters per second. So the initial momentum of A is 20 kilograms per meter second in this direction. So Pi equals Pf from the popular equation, Pi equals Pf. So this is 20 in this direction. Right, and this is 5 times 8 is 40. Now the weight mass is 5 kilograms and the speed is 8 meters per second. So the momentum of this object will be 5 times 8 is 40, and that will act upward. So this is 40 in this direction is equal to the final speed of this object, final velocity of this object is 4 meters per second and its mass is 2 kilograms, so its momentum will be 8 kilogram meters per second in the same direction as it was before. So this is 8, right? This was 8 plus